everyone, welcome back. I am Miss Bauman, and today I am going to be teaching y'all how to find the value of 6 trigonometric functions with a triangle, kind of like a little demo. What I'm basically going to go over first is just what actually all these mean. So we have sine, cosine, tangent, cosecant, secant, and cotangent. Okay? So what does this mean? So first, the 3 basic ones that we use first are sine, cosine, and tangent. And then it gets a little more complicated with these, but not really, because I'm going to explain it, and it's going to seem so easy. All right, so sine, okay? We have this thing that I learned a few semesters ago. It's called SOHCAHTOA. So what that looks like is SOHCAHTOA. All right? But first, let me go over what these all mean. So no, of course you know S is for sine, C is for cosine, T is for tangent. However, what does AH, and OA mean? So we have 3 different things that we need to consider with the triangle. First, we have theta. This is kind of like the missing value that we got to figure out, okay? So we have opposite, hypotenuse, and adjacent. Okay? So when we look at this, I'm going to explain what this means in terms of theta. So if I'm looking at theta and I go, okay, the easiest one that you can always find out is the hypotenuse. It's the longest line on a triangle, okay? Longest side on a triangle. So we look at it, this is the hypotenuse, okay? H. Now we want to say, what's the opposite of this angle right here? So what's and this kind of gets tricky, but again, you get used to it after a while once you do a lot of practice problems. Practice, 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 it makes perfect. So kind of like right here, right? And what's the line closest to that? That's not the hypotenuse, right here. This is opposite. And then what adjacent means side, to the side. So what's to the side of this theta that isn't the hypotenuse? Right here. Okay? Now, we know what all the parts mean. So we have okay? So opposite, hypotenuse. Adjacent, hypotenuse. TOA, opposite, adjacent. Now let's just start out with these and then we'll go into the rest of these, all right? So let's do okay? So looks something like this. So we have opposite, okay? So we're going to put this on top because these are all little division problems, okay? So we have 11 over hypotenuse, which is, and actually, you know what, before we go into this, we have to do one more thing, okay? We have to find the missing piece of this, okay? So first we are going to do 16 squared because that's a hypotenuse. So the equation actually looks like a squared plus b squared equals c squared, okay? But, so we know what c is. So these are the 2 sides, and this is technically the hypotenuse. So we have the hypotenuse value, which is 16, and then we square it, equals, and then we can pick whichever one we want to do. I like to keep a with adjacent, but that's just me. Do whatever you like. Okay, you can choose whichever one you want to do, but for now I'm going to do 11 squared right here, and then do a little a squared. Okay, so 11 squared I know is 121, and I don't know 16 squared off the top of my head, but I can tell y'all real quick. And I have my handy dandy little calculator. My favorite one is the TI-84 Plus CE. If you are looking for a great calculator, it is 256. Okay? Okay, a squared. And I'm just going to erase this right now. Hopefully y'all got that down in your notes. So now we're going to solve for a. Okay? So we're going to go minus 121. So minus 121. And I like to cross it out just to say it's not on this side anymore. It's now on this side. So we have a squared equals 256 minus 121 is 135. And then we're going to square root that because we have a square. We're going to square it because there's a square root right here. Or it's squared. Woo, I don't know why that took me so long to get out. All right, so let's see if it's actually possible. I don't think so, but you never know. So it's not evenly possible to square root this. So a equals root 135. All right? So now we have our missing value right here, 135. And for this video, we're not necessarily going to simplify everything. I'm just showing you how you would just set everything up and get your just division sort of base answer, okay? So you'll see what I mean as I go along, okay? So let's do so, okay? So we have opposite and hypotenuse. So opposite is 11 over hypotenuse, which is 16. Can we simplify that? No, we can't. Okay, so that's so. And then ka, which is adjacent, hypotenuse. So we have root 135 over hypotenuse, which is 16. Okay, again, I'm not going to simplify this for y'all just because we're doing it for the case of what the big picture is, okay? All right, lastly, we have TOA just for this part, okay? So TOA right here, which is opposite and adjacent. So we have 11 over root 135. Okay? So those are your answers for just this section, okay? And now we're going to get into cosecant, secant, and cotangent. All right? So actually, let me just write these over here just for y'all's notes because I got to erase. So we have 11, 16 equals ka root 35 over 16 and TOA, which equals 11 root 135. All right, cool, good deal. Okay. All right, let me just put my eraser right here. Now we're going to work on the rest of these, which is, as explained prior, cosecant, secant, and cotangent. So, what do you think? You guys are not here, but when I look at this, I say, what do you think when you look at these, what's going to go together? Obviously, we know cotangent and tangent, pretty much we can guesstimate they're going to go together, and you'd be right. Okay? So, let's just put a little TOA right here. Okay? Now, we got to think, okay, this is purely memorization. You just got to learn it. So cosecant is actually sine, and secant is cosine. Let me make this more an H. Sometimes my H's look like N's. All right. So in reality, what does this actually look like? O over H equals A over H, which equals O over A. Now, the cool thing about this is that all we have to do is flip every single one of these. Flip, flip, and flip. This is taking the reciprocal of all of these, sine, cosine, and tangent, and that is cosecant, secant, and cotangent. So in reality, these are actually hypotenuse over opposite, hypotenuse over adjacent, and now adjacent over opposite. Okay, so now let's try these with our new division signs and everything like that, okay? So what we found out. So, but there's an easier, you know what? I'm going to show you the easier way because I like taking the easy way out as far as with math, because math gets kind of confusing sometimes. So, what did we just figure out? So, right? And all we had to do was flip it. Let's go back to so. We have 11 over 16. What do you think is going to happen? It's exactly what you're thinking. Equals 16 over 11. Crazy, right? Next part, we have H over A, which was actually ka. We have, and that looks like an N. Gosh dang it. All right. Now we're going to flip it. So this is 16 over root 135. And lastly, we have TOA, which equals root 135 over 11. But I will say, what if you didn't know these at all? And you were given something that just says, find cosecant, secant, and cotangent. Sure, you could find these from this. Or you could think about H over O h over a, o over a, and do the exact same thing that we did. So h over o, let's just check our work. 16, h over o, 11, h over a, 16 over root 35, or 135, and then a over o, which is root 135 and 11. And that is the end of solving or finding the values for 6 trigonometric functions in terms of a triangle and theta.